Assalamualaikum warahmatullahi wabarakatuh. Now I'm going to discuss with you practice 1.4 question number 4. Construct a Born-Haber cycle to explain why ionic compound NaCl2 cannot form under standard conditions given all the enthalpies that you need. But here I can see that there is no enthalpy of formation. Yeah, I'm guessing here that we need to calculate the enthalpy of formation. But if you can't see it yet, now let's draw the Born-Haber cycle first. Okay, the first thing that you need to do is write the equation of formation for sodium chloride NaCl2. So the constituent element at standard condition for sodium is solid, and for chlorine is chlorine gas. So I believe this is already balanced. NaCl2, this is an ionic solid, and this is delta H formation, which we want to find. Right. The next part is we are going to fill in this column going down for sodium, and then the second column for chlorine going down, and then the gaseous ion for sodium react with the gaseous ion for chlorine will produce the NaCl2 using lattice energy. So let's do that now. Use all the information given in the question. So enthalpy of atomization is when the solid sodium becomes gas. So this is involving sublimation. So the question gives you 108 kilojoule per mole. If you don't put the unit, it's okay because all the units are the same for the whole cycle. Next, you're going to make up an ion, Na plus gas. This is using the IE. What is the first IE? 500. All right. The next one is make Na2 plus using the second ionization energy, which will give you 4,562 kilojoules. Why do you think it has a lot of energy there? Yes, because the second last electron of sodium is in the inner shell. Remember? Chapter 4, Sem 1. Okay, now we go to chlorine gas. We are going to atomize it. So it is balanced for 2Cl gas. Now, since the definition of enthalpy of atomization is when 1 mole of chlorine atom formed, heat change when 1 mole of chlorine atom formed, this is actually for 2 reactions. So the one given to you, 121 kilojoule, must be multiplied by 2. Right. Next, we are going to form Cl minus. How many? 2 moles. So this one is electron affinity, negative 364. Also, we have to multiply by 2 because there are 2 reactions over here. Now, we already formed gas. All right, we have to react them together, gaseous ion of sodium and gaseous ion of chlorine, and then they were going to produce NaCl2. The lattice energy given to you is negative 2,489 kilojoules per mole. Now, using Hess law, you are going to calculate what is delta HF. So press your calculator. 108 plus 500 plus 4,562 plus 242 plus negative 364 times 2 plus negative 2,489. So you're going to get the final answer here. Positive 2,195 kilojoule per mole. So as you can see, the delta H formation is a positive value. So this proves that NaCl2 will not exist at standard condition, because in order to exist in standard condition, the delta F formation must be having a negative sign. Heat is released. Okay, I want to talk about the marks for this Born-Haber cycle. Okay, the marks for Born-Haber cycles are generally 4 marks. Okay, the first mark would be given for a complete cycle. Complete cycle means I'm going to look at the arrows. The arrows. Is it correct? Going down, going down, going down, going down, and also going up for lattice energy. Okay, all complete arrow, and this one plus and this one plus. Usually student would left out this one, so they will not get the first mark. So be careful when you are drawing the Born-Haber cycle. Number 2, we are going to give you the marks for balance equation. Balance equation means all the equations here is complete and balanced. Meaning that, for example, some student may not realize that Cl2 will produce 2 Cl. Maybe they will just put Cl2 and then here Cl. So it means that here is 2 atom Cl. It become only 1 atom Cl, so it's not balanced. So that student will not get this second mark. Okay, the third mark is delta H labeled. Not only one, all delta H labeled correctly. Meaning that this must be labeled as enthalpy of atomization or sublimation given in the question. This also must be labeled. This is labeled, this is labeled, this, and this one. So the one that we want to find, we don't need to write lah. Okay. So the fourth mark would be the mark for phase. All correct. So solid, gas, solid, gas, 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 gas. You must not use what? Students always do this, aqueous. There is no aqueous form in Born-Haber cycle. But for students who study last minute, who study in the first lesson and then didn't look at it until the night of the final exam, they will put aqueous. Once you put aqueous for this, then you will not get this fourth mark. So as you go along, please make sure that you get all the marks completed. Okay. Okay, here is a proper Born-Haber cycle which we typed last year. Sodium solid plus Cl2 gas becoming NaCl2 solid. So you can just refer to this diagram as the answer. Now we are going to find delta H1, the enthalpy of formation, and we found out that the answer is positive 2195 kilojoule per mole. But before that, we want to look at the different type of Born-Haber cycle, which is in the form of energy level diagram. So as you can see, the y-axis is energy and the x-axis is the progress of reaction, which we can also label as reactants or products. So the bottom part is NaCl2 solid, okay, as it goes from Na solid and Cl2 gas. This is delta H formation. It is a positive one because the reactant has more energy than the product. So as we go up, Okay, we can see that the sodium is changing into gas, so this is enthalpy of sublimation. And then the chlorine is changing into atom, so this is enthalpy of chlorine. And then sodium gas atom turns into sodium ion in the form of gas using IE1 and IE2. And finally, chlorine gas will become chlorine ion gas, and both of these ionic gases will use lattice energy to produce back the solid sodium chloride. So here, this is a complete cycle going up and then going down, but then you have to calculate the delta HF, and the 0 point is actually here. So basically, delta HF here is positive, so it means sodium chloride cannot exist in standard condition. Now, for the formula, yes, delta H1 is actually the delta HF, and all the delta H2, 3, 4, 5, 6, 7 are the values that are given in the question. So you can see here, the values are inserted into the formula, and the answer is 2,195 kilojoule per mole. Okay, let's read this. The standard enthalpy of formation of NaCl2 is highly positive, endothermic. Thus, this compound is unstable with respect to its element, and it cannot exist under standard conditions. So, this is how you answer for question number 4 of the practice 1.4. Right. Next, I want to give you all the questions in the tutorial part of the course book for Born-Haber Cycle. Question number 15, Khamsata Ashara, is regarding sodium iodide. So you need to identify what are the enthalpies of delta H1 until delta H6, formulate or derive a formula, find the enthalpy of atomization of sodium, and compare the lattice energy. The answer is given to you there, the final answer. Next, question 16 is regarding rubidium bromide. Try to get the final answer here. Not that difficult. And question number 17 is regarding magnesium chloride. So you have to sketch and draw a Born-Haber cycle and calculate the enthalpy of formation of magnesium chloride, and then you have to compare the lattice energy of MgCl2. So basically, drawing Born-Haber cycle 4 marks, and then finding the enthalpy of formation 2 marks. Comparing the lattice energy is 2 marks. So there would be as much as 8 marks here. I hope you would get it all. So thank you very much for watching the video. I hope you will be able to find time to do all the practices on your own, and then we will discuss selected questions in the tutorial session, inshallah. Assalamualaikum warahmatullahi wabarakatuh. Bye.